Guys, so this last question is what do you call these topics? The applications of calculus, right? Optimization. Yes, I believe it's optimization. If I'm not mistaken, please do correct me. So this is what you're given. You're told that during an experiment, temperature in degrees Celsius varies with time. So this is the formula for temperature, right? And this is the time interval. So 8.1, we are asked to determine the expression for the rate of change of temperature. When you talk of rate of change, rate, right? We're talking of a derivative. That's what we mean. The slope, right? So we are given t of t is equal to 30 plus 4t minus 1 over 2t squared. So we want to find the rate of the change of temperature. As I said, we derive derivative of t is equals to, this 30 is going to be 0, so it's going to be 4 minus the half, and then we drop the 2, so it's 2 to the power of 2 minus 1, like this. So the rate of change is going to be equals to 4 minus t, right? So this is the rate. Cool. Now let's get down to another question, right? Where we are asked to find the time interval. So in 8.2, during which time interval was the temperature decreasing? So this is very important. Was the temperature, not the rate. There's two different things. If they said the time interval when the rate was decreasing, the rate of what? The rate of time. T prime of t, which we found to be 4 minus t, right? If they said the time interval when the rate was decreasing, you're just going to say this 4 minus t less than 0, and then you find the value of t, right? But now they didn't say the rate is decreasing, they just said temperature is decreasing. So you're going to say t of t is equal to 30 plus 4t minus 1 over 2t squared, right? So this temperature is decreasing, meaning it's going to be 30 plus 4t, or minus, sorry, plus 4t minus 1 over 2t squared, it's less than 0. Less than 0, it's decreasing. And then from here, you're just going to use your quadratic formula, x equals to minus b plus or minus the root of b squared minus 4ac all over 2a. You substitute that into your formula, right? We know our a value, it's equals to minus 1 over 2. My b value is equals to 4. My c is equals to 30. Please, I assume you all know how to substitute into your quadratic formula. So remember that we're having less than here. Take note of that. So my first t value, I got t being less than minus 4.72. or t being less than 12.72. So these are not your final answers, by the way. You need to check if these are your final answers. So you're going to write down your number line and then indicate your critical values of minus 4.72. Let me say it is a critical value, and 12.72. So you check, because they're saying decreasing, so meaning we are mostly interested where it's negative. This is what it means. So please check a value that is minus 5. Check which sign it does give you. Substitute it in this specific equation and check whether you're getting a positive solution or a negative solution. Where there's t, you just put 5. Where there's t, you put 5. Tell me what you get. And what I got is a negative solution. So I got a negative solution of y. Okay. And then here you can substitute any number between these two critical values, right? You can substitute 8. I got a positive solution and I substituted 8. And here you do the same thing. You substitute, let's say 14, or any value that is above 7, that is above 12.72. You're going to get a negative solution. Then this will help you conclude your solutions of x, right? So now, as I said, they're talking of a decreasing temperature. Something that's decreasing, it's negative, right? So now we can conclude and say, using this critical value, x must be less than minus 4.75 to get a decreasing temperature, or X must be greater than 12.72, this one here, to get a decreasing temperature. So these are your solutions of X. So we are done with this paper here. If you haven't seen other questions, please do check them out in the description of this video, or just browse through the channel. You get all the questions for this past paper that we've just done. Thank you so much for watching. If you haven't subscribed, please do subscribe. Otherwise, take care.